Hello. Okay. So today we will discuss about obtaining equations of motions for constant acceleration. The important point is constant acceleration using method of calculus. So what we will do is we will use method of calculation, means we will be using differentiation and integration basically. So let's derive the equation of motions. You know that equations of motions are v is equal to u plus at, d square minus d square is equal to 2s, and s is equal to ut plus half at square. So all these three equations of motion we will be deriving in few minutes. See, so as we will be using the method of calculus, so we know that acceleration is dv upon dt. A is equal to differentiation of velocity. So we can write dv is equal to dt cross multiplication. Now integrating both sides, what we do? Integrating both sides. Integrating both sides, what we do? dt is equal to a dt integration. See, a variable is dv, a variable is dt. So what we do? We'll take this time from time 0 to t, and the velocity started from suppose v0 to or v0 to v. Then integration, you know, if let us dx, derivative of dx is 0 to x is x, 0 to x minus 0 x. So similarly, derivative of dv is d minus, or if I write b0 to b. A is constant because we have already mentioned for constant acceleration. So what we do? A is constant, so constant will come outside. That is a 0 to t dt minus t 0 to t. So this will be d minus b0. b0 is the initial speed and b is your final speed. This will be equal to a t minus 0. So simplifying this, b is equal to b0. b0 taken right hand side plus at. b0 or sometimes we call it u. B is equal to u plus at. So this is one equation of motion. Now we will discuss the other equation of motion related to distance. So the other equation of motion, what we will do? We know another relation. Let me do it this way. So you know that b is equal to dx by dt. Rate of change of displacement, which is rate of change of displacement is your velocity. So differentiation dx by dt is your velocity. So if I write it, dx is equal to ddt. Here we have taken a outside because a was the constant, but remember here b is not constant. B is not constant. B changes. Acceleration constant does not mean b is constant. Velocity is constant. Velocity is changing. Okay, so we cannot directly take out of integration velocity. So what we do? We will put this value of v from here, equation 1. So let's integrate. Similarly, integrating both sides. dx is from x0 to x, started from some point x coordinate, some height and x point. Then here time is again 0 to t. Now we can write it. Here it will be x minus x0. Similar process. b minus b0. Upper limit minus lower limit is equal to v we put here from here. V is equal to v0 plus t. That is v0 plus at whole dt integration 0 to t. Now this will be equal to say integral v0 dt 0 to t plus at dt 0 to t. This is your x minus x0. Now x minus x0 is equal to, this will be v0 is a constant, starting velocity, initial velocity you can say. So it should be v0 dt integration is t minus 0 upper limit minus lower limit plus at dt. A is constant, it will come outside. T integration is t square by 2 minus a lower limit is. So simplifying it, x is equal to x0 plus, or you can write definition, x minus x0 is equal to v0 t plus half at square. That is x minus x0 is a distance or displacement travel. So you can write here s is equal to v0 t. V0 is initial velocity. You can write u also. Ut plus half at square. That also v0 to write. We have taken, you can write that v0 is equal to u. Now we derive the last equation. Now let's derive the last equation. So deriving the last equation of production. Now we use chain rule. Chain rule you might be knowing. The chain rule is that you know that we can write in this way that A is d by dt. Velocity is a function of x and x is a function of t. So we can write using chain rule dp by dt is equal to d by dx. You will learn this chain rule dx by dt. dv with respect to dx and dx with respect to dt. So we are using chain rule. So using this chain rule, what will happen? Say dv by dt dx and dx by dt. Dx by dt is what? V. So we can write v dv upon dx. Or we can write what we can write and plus that cross multiplication a dx equal to v dv. Now similarly integrating both sides A will come out dx x0 to x is equal to b0 to b, b will be b. Here is the variable. So what will happen here? Now a here dx. So upper limit minus lower limit integration. In one video I will show you how to do all this integration. Is equal to b dv integration is b square by 2 upper limit minus lower limit b0 square minus 2. So simplifying it, 2a x minus x0 is equal to b square minus b0 square. b0 we can write u and x minus x0 we can write s. So we can write this 2a s. X minus x0 is displacement. The distance curve. Suppose this is your x0, this is your x. The distance over the displacement s. So you can write b square minus u square. This is your last equation or equation number 3. Here we have taken x minus x0 as s, and here this one is the equation number. This one is the equation number 2. Okay, so this is the description or derivation of 3 basic equations of motions using method of calculus. And this formula, there is some point like these things using chain rule. These things you will learn in your mathematics classes in class 12, or you can see, say, you will be in this class also you can practice derivative or differentiation more. Okay, so in next talk we'll discuss other things. Thank you.